Welcome back to my channel. Anyway, so today we'll be talking about family groupings. So the elements of any particular group, so that's columns in the periodic table, all have the same number of outer shell electrons. So remember, group 2 elements have 2 outer shell electrons. Elements in group 6 have 6 outer shell electrons. So for this reason, they tend to form ions of the same charge or have the same number of covalent bonds when forming a molecule. So this causes most compounds constructed from them to be similar. So just to further clarify what I mean by this, here is an example. So what you see on the screen here in the blue column is group 2. So every element in group 2 is a solid metal. And when bonding with a nonmetal, so that's ionic bonding, each forms an ion carrying a charge of +2. So remember, metals compared to nonmetals have a weaker hold on their outer shell electrons. So because elements in group 2 have 2 outer shell electrons, so they will be donating 2 valence electrons, so 2 outer shell electrons to the nonmetals that they are bonding with. So remember, atoms both have the same amount, all have the same amount of protons and electrons. So if you're losing 2 electrons, you are more positively charged, so that's why there's a +2. So for this reason, they all form similar ionic compounds with the nonmetal that they are bonding with. So on the screen here is chlorine in group 17. So it has 7 valence electrons and needs 1 more in order to have a full outer shell. And then what you see on the screen here are 4 of the elements in group 2. And each of them have 2 outer shell electrons. So when a metal, remember, is bonding with a nonmetal, the metal loses its electron. So just like that. So now chlorine, because it gained an electron, it has a full outer shell now. But what you do notice on the screen here is that there's still an extra electron left in the outer shell. So what happens is beryllium just donates it to another chlorine atom. So all of the elements in group 2 will all form similar ionic compounds with chlorine. So what this means is if I were to use magnesium, so Mg, instead of beryllium before, I would still get the same outcome because they all have 2 outer shell electrons. So therefore they would have the same ratio of 1 to 2, so 1 metal and 2 chlorine in this case. So this is shown in their formulas, so MgCO2, CaCO2, SrCO2, and BaCO2. So that means
I don't work for much.
I didn't talk to you, Siri. So that means 1 magnesium to 2 chlorine. So likewise, each of the elements of group 17, so that's what you see in the yellow column there, form the same number of covalent bonds and therefore form similar molecules. So for example, if hydrogen bonded with any of the elements of group 17, they will form similar molecules such as HF, HCl, HBr, and HI. So here's a visual representation of what I mean. So hydrogen has 1 electron, and remember, when nonmetals bond with each other, it's covalent bonding, and that means they are sharing. So hydrogen is sharing its 1 electron with fluorine, which has 7, to both have full outer shells. And similarly the same with chlorine. So however, the elements in each group are not the same. So this is because every new period, so that means row, represents a new shell being added to the atom. So on the left hand side of the screen, that column there is elements of group 1. And as you go down the list, if you look at the atomic structure on the screen there too, so hydrogen has 1 outer shell, lithium has 2, sodium has 3, potassium has 4, etc. So as you go down the rows, there is an extra shell being added. So therefore the outer electrons are a little further out from the nucleus and held less tightly. So hence a gradual change in physical and chemical properties is observed as you move down through the atoms in each group. So predicting chemical equations, so elements of the same group tend to react in very similar ways, and so a balanced chemical equation for one element can be used to predict the reactions for other elements in the group. So for example, the balanced formula equation for the reaction of fluorine with hydrogen sulfide is F2 plus H2S, and then the product would be S plus 2HF. And the reason why it's like that is because if you look on the left hand side, so the reactants, there's only 1 S, so that's why it's by itself, and then there's 2 H's and 2 F's, so that's why there's a big 2 in front of the H and F. So remember, fluorine is in group 17. So the other group 17 elements will react in similar ways as well, and so it can be expected that the balanced formula equations will be similar too. So hence you can predict that their reactions will most likely be like this. So it's basically the same, just replace the group 17 elements letter instead. So chlorine 2 plus H2S plus equals S plus 2HCl. So, and the same will be, and it will be the same for the other elements in group 17 as well. So element families, so we have already learned that the periodic table is categorized into metals, metalloids, and nonmetals. However, some groups belong to certain families. So the columns on the periodic table are called groups, as I said before, but they can be also called families because of their similar chemical behavior and chemical properties. So this was the original periodic table that I showed you guys in our first lesson when we learnt about it. So all I showed you guys was how it was split into metals, metalloids, and nonmetals. So because we're talking about their families today, and we're talking about 5 of them, but there's heaps of families, but we're only talking about 5, it's color-coded differently into their families. So we'll be focusing on alkaline metal, alkaline earth, transition metals, halogens, and noble gases. So group 1, so what's highlighted here in that red, is called alkaline metals. And if you notice, hydrogen, even though it's in group 1, it's not actually in it. So hydrogen is not considered an alkali metal because the gas does not exhibit the typical properties of the group. So however, under the right conditions of temperature and pressure, hydrogen can be an alkali metal. So what exactly are the properties of it? So alkali metals are the most reactive metals. They form +1 ions because they're losing 1 electron. They react violently with water. They have typical metallic properties, so shiny, malleable, ductile, etc. So that's group 1. And then you have group 2, which is alkaline earth metals. So alkaline earth metals are less reactive than alkali metals. They are harder and denser than the alkali metals due to having 1 more electron in the outer shell. They contain 2 of the most biologically important metals. So magnesium is found in chlorophyll and calcium is found in teeth and bones. So from groups 3 to 12, that's in the yellow there, they are called transition metals. So transition metals are both ductile and malleable and conduct electricity and heat. They are unique in that they can have a valence electron in an inner shell, not just the outer shell, whereas other elements can only have it in the outer shell. They can use the 2 outermost shells to bond with other elements. So like I said before, most elements can only use electrons from the outermost shell. And then in group 17, so on the right hand side, are the halogens. So halogens are a group of reactive nonmetals. They are not found in nature in their pure form, but are found in various types of salts, including sea salt, and they change state as it moves down the family at room temperature. So fluorine and chlorine are gas at room temperature, and then when you go down, it'll be liquid, and as you go further down the family, they are solids. The elements at the bottom are solids. So halogens have melting points and boiling points that increase with increasing atomic number. So remember that each period or each row, the atomic number increases from left to right. So halogens get bigger and become less reactive as you move down the group. And all of the halogens form molecules, each being made up of 2 atoms. And then the last group that I'll be talking about, is not group 5, it's group 18, and they are the noble gas. Noble gases are colorless gases. They are a group of unreactive nonmetals. They are found in small amounts in the Earth's atmosphere. And that is the end of the topic for chemistry, or in particular periodic table. So what I'd like you guys to do is just to do the unit reviews for the past 3 topics that we were learning about. So it was atoms and elements, so that's 4.1 unit review. And then it was the periodic table, which is 4.2 unit review, and then 4.3 unit review is about what we learned last lesson, so bonding. Bye.